The nervous system is like the central computer in the brain, and all the nerves are the wires sending and receiving signals from all over the body. It is so complex that even a computer can't meet its sophistication. That being said, the nervous system is one of the most key foundations for the study of kinesiology. Without the communication of the brain to the muscles, there would be no movement. With no movement, there would be nothing to study. No movement equals nothing. Before we go into the effects of the nervous system in the realm of kinesiology and how it impacts its study, let's get a better grasp of the nervous system. There is no actual date or discoverer of the nervous system because a bunch of people puzzled it together over centuries. However, Greek philosopher Aristotle developed a nervous system theory that the body had a network of nerves that led to the heart. He was later contradicted by Roman physician Galen, who concluded that the brain was the center of the nervous system. He saw that the spinal cord emanated from the brain and that all nerves networked through the body to control the movement of muscles and limbs. And from there, philosophers and physicians were able to further explore the complex system that is the nervous system, to bring to light the different aspects of it and how it controls the body. So we know the nervous system is like a computer, but how do live tissues work like a mechanical electrical component? The explanation is not simple. It starts with the fundamental component that is a neuron. The neuron is responsible for receiving and sending signal to and from other structures in the body. Its structure is built to essentially receive a message and then translate that message and send a response to wherever it needs to go. Kind of like a post office, where mail goes in and mail goes out, but a wee bit more complicated than that. As I said before, this system is pretty complex. So of course, it goes beyond just motor neurons. The nervous system branches out to two general divisions, the central nervous system and the peripheral nervous system. Let's begin with the central nervous system. The central nervous system, CNS for short, is composed of the brain and the spinal cord. Its major function is receiving and interpreting info gathered from sensory organs about the inside and outside of the body. The coolest part of the CNS is its main source of info processing, the motherboard of the body, the brain. The brain is the most fascinating, most complex organ in the body. It stores 1 trillion bits of information over its lifetime, more than your iPhone can for sure. Although the brain functions as a whole, it is divided into different sections, all responsible for many functions. Brainstem is responsible for regulation of certain muscular reflexes associated with posture, is in charge of regulation of cardiovascular, respiratory, and digestive systems, and it helps control arousal of cerebral cortex, and it acts as the sleep center. The cerebellum assists in the maintenance of balance and muscle tone and contributes to coordination of voluntary movement. The hypothalamus assists in the maintenance of body temperature. It helps control thirst and food intake, and it helps regulate urine output. It also contributes to the control of emotional behavior. The thalamus serves as a major relay station for all synaptic input, and it contributes to some crude awareness of sensation. The basal ganglia contribute to the initiation of voluntary movement. It assists in the coordination of slow voluntary movement, and it acts as an inhibitor of muscle tone. The cerebral cortex is responsible for complex mental functions such as thinking, memory, creativity, and decision making and language. It interprets conscious sensory information and it is responsible for the voluntary control of movement. I could go on and on forever about the brain itself, but we don't have any time, nor is it relevant to today's presentation. Working alongside the brain is the spinal cord. It serves as a relay station in that it contains the motor and sensory pathways that link the brain to the muscles, glands, sensory receptors, and other vital organs. but most importantly, it plays a major role in the function of reflexes and locomotion. The peripheral nervous system includes 31 pairs of spinal nerves containing both sensory and motor nerves, as well as sensory receptors for vision, touch, taste, hearing, smell, and proprioception. The nervous system can be further divided into other subcategories that explain its function, but let's move along to its effect on the realm of kinesiology. In order to study motion, one must go far into depth on how motion begins, and that is through body communication. With neurons firing signals into the muscles and limbs of the body, an individual is able to move. Those neurons deduct what movement will happen based on the information it collects from the sensory organs. It does it in milliseconds. So when your hand touches something hot, your skin sends pain signals to move through your arm to the brain, where it is processed as pain, aka move away, and that message is sent back to your arm, where the body reacts and the hand pulls away. It's crazy how fast that happens. Well, this kind of info processing can be seen in sports, with athletes making quick reactions in sporting events, like a tennis player moving quick to hit the ball before it reaches the ground, or a basketball player reacting immediately to someone going for a shot. All that info they are gathering is being processed instantaneously through this network in our body that then gives info on how to react. This is fascinating to kinesiologists who study how our body works and what muscles are triggered and contracting. It's a whole process. And although we continue to study, there are still many, many things we discover constantly. The nervous system is incredibly complex, and the brain has many things yet to be discovered.